Hello friends, welcome back to my channel. So today's topics related to automotive plastic products or interior exterior trims design. The most important topic, the name is to create the sections of given input for the proposals, for the benchmarking, and to share with customer as a basic feasibility or with vendor and suppliers or the service provider designs companies, okay, or organizations. So for that, in that we have to add the b-sides mounting, or we have to make that section as a parametric because it will get modify multiple times. So let's start this task, how to create the master sections from the given topics. So to get this file, download my Play Store app and also visit my website where I provides the training, and the link is given for both in the description box. So let's start the model to create the section. So this is the input whatever we receive. So we receive the A surface, and now our task is to create the section. So how to create the sections? So for that we will move. So section should be parametric. Okay. So first whatever receives the surface are individuals one. So we will make one temporary join. So for that I will switch to the generative shape design module. In that go for join, and under join selects one surface, then change the merging distance, then go for distance propagation. And once you are in a distance propagations, the merging distance is depends upon your projects and program. So then make it okay. Now we have the temporary join. So first, to create the section or any work, we required the main is the MTD, means pulling direction, dot direction or demolding direction. So for that, how to find the pulling direction or main tooling direction, I already prepared one video on YouTube. The I button given link in also in description box. So go and watch that video. So now I am finding the main tooling direction. So for that, go to measurement, select this moment of inertia, then select this join. So once you go to moment of inertia, select the join, uncheck this box, then create geometry, and then go for this, take a CG and then OK, OK. So now you have one new geometrical set with the CG point. Okay, so just isolate that point. So there should be no link with any surface and delete this measurement. Yes, now go for the line, take a line and select as point and direction. So select as point and direction as a Z direction, because if you put your part in isometric view, then it's following the Z direction. And always keep the tooling direction in B sides and make it OK. Then change the property of tooling directions and rename it as a main tooling direction or demolding direction, pulling direction, draw direction, and go and change the property of it. So make the, as per CAD methodology, always tooling direction color is the magenta, line type is 3, and make it dotted. So once you have the tooling direction, now need to make the sections for this a given A surface. So for that, now we need the plane against which we are going to make the section. So first we will make the sections in the length, okay, and then we will create the section in the width. So now I will unhide this section. The name of section is ZX plane. Now I need to go into first under the sketch module. Sketch, second option is there. Then select the plane, then change the V and H, then as per OK, make it OK. Yes, now we are in a sketch model. Okay, then go for the next one. Which one is next? Next one required is the project. So go to this project, and in projects select this project's second option. okay, intersection, and then selects your join. Once you select your join, then whatever is the surface intersection with this plane, all curves are highlighted. I will hide for you so you can understand. So this is the section, which is the A section, because we created from the surface whatever inputs we have, right? So now section is there. Yes, now this one is the A section, A surface. So need to create the B section for the thickness of the part, right? So for that we have to prepare the B, and next one required is the C surface. So how to create it? Offset curve, this is the offset one. So take this command, then come into your all curves, and now you have to select it all and put the offset value. So here you have to put the value. If your part thickness is 2.5, then put its 2.5. Yes. So now you have the B section. Which one? B section. Now you need to create the for this remaining also. So same, first select the offset, then select this curve, then select the remaining curves also. You can make it by one also, or you can select it together also. So this is the remaining one, we will make it that also. So for quickly it's better to select all at once. Yes. Now we have the B sections. So at the same times we need to create the C sections also. So for that now go for the draw. So go to profile or line, and then select this point, and then select this point. So now we have the C surface here. So in this part one, cut out at middle. I will show you the surfaces. So one cutout at the middle. So there also we have the C surface, right? Then how to create that C surface? So I will show that. So make it again normal with this plane. Yes. Now here we need to create the section, but it's ideally how it will be. It will be in angle. So clear in core or cavity. It should be like this, or it should be like this. So it will be like this, or it should be like this. So it depends upon the fitment part or environment part. But for now, as a moment, we are making it straight. Okay, that I will explain details in training. How to clear the C surface also in the draft analysis. So now this one is C surface. So now we have the all three sections. So this one is A section. Okay. Then second one is the B section by thickness, and third one is the C section. So we have the three sections in length, because your part is now in this length. Then exit from this sketch. Before that, one more important thing, you have to constrain it. You have to constrain. Constrain means dimensioning, because in future if you want to make any changes, you can make by that dimensions. But for time being, now I am not constraining it, but you have to constrain it definitely. Yes. Now we need one more section in width. So why we required the one more section in width? Because we are sharing or proposing or making a benchmarking, means we are representing the maximum informations related to parts. What is the informations? Length, width, thickness, means shape of part, size of part, then thickness of part, then number of features on part, the locations of feature, which features, cutouts informations, gap flush clearance informations, means the section is the communications language. Section is we can call it as a communications language or method of engineers, trims design engineer. So by sections you are representing what you want to say. Okay, and how this part we will make feasible by considering the all tooling, manufacturing, assembly, testing, safety, all things we are considering and we are preparing the sections. Okay, means we are going to the next step. Okay, and the remaining work is the CAD related work. Yes, so how, for that we have to share the maximum informations. For that we need to prepare the section in width also. So how to prepare the section in width, how to take it? So for that we have to take the plane. So how you can take the plane? You have to take this plane offset by the specific distance. So this one is the distance. Then now you can take the section at this location. Then take the plane, again go for position. Now take this one, then check the H and V. V is downward side, so make it upward, and this one horizontal. Okay. Yes, now again go for intersection option and select the surface join. Okay, now you have your section. So see, now I will hide for you this plane so you can understand. So see, by this you are able to understand there is a cutout. So we are sharing the maximum information related to part. You have to take a one by one. Yes, so make it 2.5 and the opposite side also make to create as 1.5, 2.5, sorry. Yes, and for again C surface you need to take the curve or line and make these two curves as close as a C surface. So this one under cutouts also, and this one at the top locations also. It's a clear. Then you have to constrain it, miss give the dimensions and then exit from sketch. Now I will hide unhide the surface so you can understand. So see, this one is the sections at right location. If you given the section here, if you given the section at these locations, what's happened? The cutout is not clear, na? So you have to create the section, that section will share the maximum information. Okay, that should be your location. So I will hide the length section also. So now by these two gap you are able to understand the length and width of that cutout. Yes. Now we created the section, uniform thickness sections of A surface, B thickness and C surface also. It's a clear. Now we have to add the features into this section. So how to do that? So for that again same we have to follow. What? Draw method. If you have the dimensions of feature, then you can directly draw the features in the sections. So that is the one method. And the another method is there. Yes, now I will hide this for a moment. Yes, now I want one features at these locations. So I want here a snap. Then you are able to draw that snap by whatever the draw features you have. So to start with draw the features, you have to start with the profile, then directly make one vertical line. So before that in this window you have to see by how much dimensions you are going upward side, because you have to see these dimensions, because if you not follow the dimensions then constraining is too difficult. Okay, so now I come to this, then take it as like this approximately we have to draw, then like this, like then this one is your engaging angle and then connect this. So this one is the feature. When you will draw the features, you can draw the snap, you can draw the clip towers, cutout or section, you can draw the welding cylinder, screw boss, star locator, impression, depression, any kind of thing. Once you done with this, You have to dimensions it, huh? You have to constrain it. For time being I am not giving the dimensions because no one have the patience to watch video till the end. I am cover quickly things. So this is the feature. If you want to add the features but you don't want to make the sketch, then you have to keep that features in your section. So like this. So I already put it one whatever reference part I have now. I taken one feature from that. I power copy here, and now what I will do, I will go into the section. Okay, and then I directly take the intersections of this body with that section. Then if I hide this body, then I have directly my section. So by these sections you can easily understand it's a screw boss. Here is the origin point, and you have to prepare the environment part cut out here, right? So the screw will be come over it. It's clear? So now you have to give the dimensions to that also. So we prepared the section for the A surface for proposals. So in proposals what will be there? Thickness is there, size, length, width, height as I already explained. Then thickness is there. Then we have the features also. Then features locations depends upon the RPS, means reference position system, which is the degree of freedom. Then cutout also there. Then we have to see the toolings requirement. Then we have to see the assembly requirements, two-way locator, four-way locator, gap, flush, clearance, each and everything. Now if one more environment part is there, then we have to consider if two parts are there in a plastic, then both parts are like this. So always not like this part. So you have to prepare one parts having the overlap flange on the other. So there will be the no rat hole. So here we have to maintain the gap and flush situations depends upon the part, and then we will provide the features here between these two on the hidden back sides. So now you have to modify this. Then how to modify? Then again double click it. You already given the constraint, then you are able to edit it. Now I will make some changes in it. So if I want now to make one flange to this part, then I will go to offset and I will make this offset by 2.5 again. So 2.5. Yes. Now I want a offset flange by some distance. Then I will offset this surface, this A by some distance. I will make it by 10. Now you have to make it close. Now you can draw as per your requirement. Whatever you want to draw, you can able to draw it. Not an issue. Take as again trim. Take this. Make this one. Make this one to this one. And this to this. So what I am created now? Here I am modify the part. So likewise you are able to modify by these sides also. Here also you are able to do like this. In width also. So initially we have only A surface. So from that A surface we created the section, and in section we applied the feature. We applied the feature. So here we apply the snap. In this we applied the screw boss, and then here added the flange. So this flange we can add the overall sides, four sides. Yes. So now you have to make the close volume for this. So likewise, if you prepared here snap, so you can prepare the cutout for environment part here na, as a section. And here having the screw boss, so you can prepare the cutout for this screw boss in the environment part as a whole. So you are able to prepare the sections for fitment environment surrounding parts also. Okay. So likewise you have to create. Hope you can understand these things. So again, for if you require this model, so please download my Play Store app and also visit the website, so you will get this model there. Link given in descriptions, and for your informations I will provide the plastic product design automotive interior exterior trims designs on Catia. So please like, share and subscribe the channel. And if you want the close volume of this, then please comment so I can make the video for the close volume on this also. Thank you.